Hey guys, I just wanted to give you guys a quick little video about the differences between angular speed and linear speed. This comes from 6.1 in our textbook, and as I'm doing this, I'm looking at page 477, which has our formulas, has a couple examples. So linear speed is something we're used to. Okay, it's how much time it takes to cover a certain distance. We might measure that in feet. We might measure that in inches. We might measure that in miles. Okay, miles per hour is an example of linear speed. Angular speed we're less used to. Okay, angular speed is how long it takes to cover a certain angle rotation. Okay, so if you think about a Ferris wheel. We've been talking about Ferris wheels recently. A Ferris wheel, how long does it take to do one rotation that's covering 2 pi radians, or 360 degrees? So our angular speed is usually measured in something like radians per unit of time. So maybe radians per second, or degrees per minute, something like that. Okay, it's an angle measurement per unit of time, whereas linear speed is in maybe feet per second or miles per hour. All right, so let's look at an example. This is again on page 477. It says a boy rotates a stone, he's swinging it around above his head. Okay, the rope that it's on, or the sling, is 3 feet long, and he swings it at 15 revolutions every 10 seconds. Find the linear and angular speeds of the stone. Okay, so we need our two formulas here. So let's go with angular speed. Okay, that formula is omega, this kind of curly W, equals theta over t. It's the amount of angle per time. Whereas our linear speed is the arc length covered over time. So we say V equals S over T. Okay, and so if we think about this problem, if I want to find the angular speed, okay, I'm going to need to know how much theta, how much angle is covered in the amount of time. Well, I know the amount of time is 10 seconds. All right. How much angle is covered? Well, 15 revolutions, so it's 15 times around. And one time around is 2 pi, so it's 15 times 2 pi, which would be 30 pi over 10 seconds, which gives me an angular velocity of 3 pi radians per second. That's my angular velocity. Right? Now, to find the linear velocity, or the linear speed, right, I have to figure out the distance traveled. All right, so now I'm not talking about the angle being covered, I'm talking about the actual distance that it's traveled. So my linear speed is going to be s. All right, so let's see. What is the distance, the circumference of this circle? Because I know it's going to go 15 times around, right? So the circumference, well, my formula is 2 pi r. So that's 2 pi, the radius of the string is 3 feet, so times 3. So that's 15 revolutions times a circumference of 2 pi r, 2 pi times 3, in a time of 10 seconds. So that's what, 90 pi over 10 seconds, which gives me a velocity, a linear speed of 9 pi, what were we measuring in feet? Feet per second. Okay, to finish up, it would be really nice if we could have a way to kind of connect linear speed and angular speed. All right, and it comes from a formula that was earlier in the chapter. All right, it was about our arc length. It was S equals R theta, which led us to theta really is the arc length over R. Okay, well, if I started with my linear velocity formula, which I know is S over T, S I know is R theta. So I could rewrite S as R theta over T. Okay, but our formula from the previous page, theta over T, wait, that's angular velocity. So I get R times angular velocity, which is W. So we get this nice formula, linear speed is the radius times the angular velocity. Okay, and that can help us convert between the two. If we know one, we can find the other. So to finish off, let's do this other example on page 477 about the woman riding her bike. They've got 26-inch diameter wheels that are rotating at 125 revolutions per minute. We want to find the speed, the linear speed. Okay, so I'm trying to find V. Right? And I have a couple formulas for V. There was V equals S over T. That's not a good S. V equals S over T, or there's also V, the new one. So here's S over T, which was RW, or R omega. Well, I know something about its angular speed, 125 rotations per minute. So I ought to be able to calculate my linear velocity, my speed, by using the RW part of this formula. Okay, so my radius of the wheels is 13 inches. And now my angular speed is going to be theta over, because remember W equals theta over T. So it's going to be theta over T. Okay, so RPMs, that's revolutions per minute. So in 1 minute, I know I'm doing 125 revolutions. So my angle is 125 times 2 pi. Right, so in 1 minute, I'm going to cover an angle of 125 times 2 pi, which is 250 pi. And if we multiply that out, what we get is 3,250 pi inches per minute. All right, that's my linear speed, but I gotta now find it in miles per hour, so we're just gonna convert using some of our known amounts here. So if I need to get to hours, all right, so I'm at 1 minute here, so I need 60 minutes per hour to multiply there. And then I'm also in inches. I need to get that up to feet and then up to miles. So that would be 1 foot per 12 inches. And then 5,280 feet in a mile. So 1 mile per 5,280 feet. Okay, I got a room there. And let's multiply that all out. So we would get, let's see here. So if we multiply that all out, you get 195,000 pi over 663,360 miles per hour. That's meaningless, so let's find the decimal. And you divide it all out, you get about 9.7 miles per hour. Okay. Hope this helps with the linear and angular speed. We'll talk more about it next class.